Hi, my name is Satvik, and this talk is about hardware-efficient architectures for scaling qubit readout. Qubit readout is a fundamental operation in quantum computing. It involves collapsing the state of a qubit into 0 or 1. Readout involves sensing a very small analog signal that passes through a noisy environment before it is digitized by analog to digital converters. As a result of which, readout error rates are really high on most quantum computers. This graph shows the worst case readout error rate on different IBM quantum computers. So the baseline design that we compare our work against enables higher accuracy by feeding the entire readout signal to a very large neural network. But this approach is not scalable because of the complexity of the hardware used to implement the feed-forward neural network. So we aim to design a readout classifier that is accurate and hardware efficient. So readout is a classification problem. The readout signal that is received from the qubits is split into I and Q channels, which are then digitized and then filtered. The classifier then decides whether the filtered value is 0 or 1. Typically, a scatter plot would look something like the image on the right, where you can see a clear distinction between 0 and 1. However, this is a very ideal picture, and in reality, it would look something like this, where a lot of the measurements corresponding to state 1 end up in the region occupied by state 0. This is because of relaxations, and it is a major source of errors as shown in this chart, which signifies how relaxations affect the accuracy of detecting state 1. So the key insight of our work is that these relaxations, in this case, relaxations are shown by the red diamonds on the left image. These relaxations can be detected, and we use match filters to detect these relaxations. And a quick run through of our design, which we call Hercules. Hercules is basically a hierarchy of classifiers. So the first level of classifiers are basically match filters and two different kinds of match filters. And the outputs of these match filters are fed to a very tiny neural network that then discriminates the state of all 5 qubits present in our system. So in terms of accuracy, the advantage of using Hercules is that we get a 16% relative improvement in the overall readout accuracy of 5 qubits. In terms of hardware utilization, we see orders of magnitude improvement in the hardware utilization on a Xilinx FPGA. So to learn more, we hope to see you at our session